Okay, so we created this this series of nodes that can animate the normal maps. So we have a look at that currently. All I've done is I finished it off and I've attached the normal output to the normal input of the water material, and obviously I've compiled it and you can see the results on that. And when we've saved it, it's now being applied to the instance, and you can see that we can see the normals, the surface affecting the surface, and that looks pretty good. But the problem is you can see that the normal texture doesn't really change, and really water, the ripples over time, they actually move around and they change. And at the moment you've probably also noticed that there's no refraction, there's no change of where the edges are, there's no distortion of the objects that are submerged underneath the water. So there's a couple of things that we need to change on here. Okay. And there's no change in the reflective material of the object due to the change in the roughness. So there's a couple of things we need to change. Right. So that's the next thing that we're going to do. Okay, so we're going to focus on the refraction and the roughness of the material, and we'll come back to the normal because we can do a more complex process to make that change over time. So we're just going to break that. Okay. And we're going to do a couple of things here. We're going to drag from RGB from the texture sample from the normal, and we'll just call it mask. And just make sure we click on that normal that we're only getting the red and the green output from there. That's what the mask does. And we're going to multiply that value. So multiply, and instead of putting something to multiply in, you can actually just put in constant B and multiply that by twice as much. So that will increase the values of those two. And then we're going to append those. Now what append does, that means adding that to something else. So use append vector. Okay, so done that. And what we're going to do now is we're going to append that to the next section, and then we just append it to the blue channel. So we just drag that to the blue channel, and we'll just make another one of those. Just make it a bit more tidy. By double clicking on it, you create a new node. Okay. We'll eventually be using this again. So that will append that to there. And if we click on that little diamond at the top, it'll create another picture, and you can actually see what it's done. It's increased the intensity of the normal map, and we can use that as our basis for the other factors, so which we'll look at in a second. Okay, we're going to look at the refraction part now. So first of all, select water tutorial, the material node itself, and go down to refraction. If you can't find refraction, you type in refraction, and instead of refraction mode being index of refraction, just drop that down and select pixel normal offset. This is for this particular case. Any other case you can leave it the same. Okay, and this will take the pixel information from the shader to determine the refraction, and we're going to pipe this into here now, into refraction. and that will compile the shader. I'll come back to that when it's finished. Okay, so we've created the panning texture that has been multiplied more to emphasize the refraction. As you can see now, we're getting refraction of the water for the objects that are cutting through the surface. Okay. So it's starting to look a lot more like the water, but we've still got this problem where effectively the normals look the same, or the ripples look the same. Okay. I'll just show you that what's happening inside. So what I've done inside at the moment is I've done the mask RGB, multiplied it by, appended the blue channel to emphasize it, and then I've wired that directly into the refraction. But you've probably noticed as well that I've made a new node and created another path for the original panning texture, the normal texture, directly into the normal. Okay, that's just a temporary measure at the moment, just to show you the results, and that could suffice for your water if you wanted it to. But we're going to go a step further. Okay, so I'm just going to break that for the time being. I'll just get rid of that node there. You can leave that node in there if you wish. There's no need to break that off. Okay, so we'll come back to that in a second. Okay, we're going to deal with the roughness now. Now that will determine how reflective the water is going to be as it ripples. So we're going to use a Fresnel node first. So type in Fresnel. Okay. And that's going to be wired up to the roughness parameter. And we had some parameters inside of Fresnel. So instead of exponent being 5, make it 1.5, and base reflective reflection 0.1, and the normal connection will go from the normal out from the appended normal. Yeah. But before going into the, just break that. That needs to be go into linear interpolation, and then that goes back into roughness. You might want to move these out a little bit, and then we're going to create 2 scalar parameters. Create another one. We'll just wire these up here into B and alpha. Okay. Effectively, what Fresnel does is it determines the magnitude of the pixels depending on the direction of which you're looking at the pixels from. So we need to put some parameters into there to help us. Okay, so in this parameter, we're going to call this parameter parallel roughness. Parallel roughness. 0.5, and then the other one is perpendicular roughness. Sorry, parallel roughness 0.1. So just to 0.1, and just temporarily I'll just take the normal just to see what it looks like. I'll just write that into the normal, just compile.